You know that feeling, right? You're right in the middle of something important, and bam, your app just freezes, or a website takes like forever to load. It's so frustrating. Well, it turns out there's a real science to why that happens, and, more importantly, a science to fixing it. So today we're going to dive into some of the big ideas from Henry H. Liu's book, Software Performance and Scalability, to really understand what makes our digital lives tick, or, sometimes grind to a total halt.
Oh man, that spinning wheel of death. The app that just gives you the silent treatment, we've all been there. And it's more than just a little annoying, right? It totally stops you in your tracks. But what if I told you that behind all that frustration, there's this fascinating engineering puzzle just waiting to be solved? A puzzle that, honestly, can make our digital world so much smoother.
Okay, so to get our heads around this puzzle, there are two key words we gotta know. Think of it like a restaurant. Performance, that's how fast the kitchen can get one single meal out to a table. Scalability, that's how many customers the restaurant can handle during the crazy dinner rush without the whole place just falling apart. Both are super important, but they are totally different challenges.
All right, so speed matters. A lot. Whether we're talking about one meal or a million. And when things slow down, it's not just about us losing our patience. For a business, a slow system can be an absolute disaster.
I mean, just imagine you're running an online store. If your website is slow, people are just going to click away and buy from your competitor. It really is that simple, but it gets even more serious. A lot of companies have contracts, actual legal documents, that guarantee a certain level of performance. If they don't deliver, they can face huge financial penalties. It's like that pizza place promising your pizza in 30 minutes or it's free, except in the software world, those promises are ironclad.
So with so much on the line, you'd think engineers would have this down to a science, right? A foolproof way to make software fast? But here's the crazy twist. The most common way people try to fix performance problems is often the very thing that makes them even worse.
And this is a legendary saying in the programming world, and for a really good reason. It's kind of like trying to make a car go faster by polishing the hood. Sure, it might look shinier, but it's not going to do a single thing for your speed. In the same way, when developers try to optimize code without knowing where the real slowdown is, it's usually a huge waste of time, and can even create totally new bugs.
Imagine your software is just a bunch of pipes. The water can only flow as fast as the absolute narrowest point in that whole system. That's your bottleneck. And the really tricky part? That narrow spot is almost never where you think it is. It's like a hidden kink in a garden hose that's slowing everything to a trickle.
So, you see, the real enemy here isn't necessarily bad code, it's good intentions that are just misguided. It's that temptation to just dive in and start fixing things without really understanding the root cause. It's the classic mistake of just guessing in the dark and hoping you hit something.
So if guessing in the dark is the problem, what's the solution? Well, it's simple. Turn on the lights. It's all about moving away from that guesswork and embracing a much more scientific method.
And this is where it all clicks. Instead of treating software performance like some mysterious dark art, we can treat it like a science. Think about it. If you're not feeling well, you don't want your doctor to just guess what's wrong, right? You want them to run tests, look at data, and give you a real diagnosis. The exact same thing applies to software. We have to stop guessing and start measuring.
And this isn't just some vague philosophy, it's a very clear step-by-step process. First, you got to figure out how the system performs normally. That's your baseline. Then you put it under some real-world stress. While it's working, you measure everything. How busy the processors are, how much memory is being used, all of it. That data points you straight to the true bottleneck. Then, and only then, you make a change and you measure it all over again to prove you actually fixed it. It's a powerful cycle.
Okay, so how do we actually find these sneaky, hidden bottlenecks? Well, it's time to put on our detective hats and start the investigation. The investigation always starts at the scene of the crime, the hardware itself. Is the computer's brain, the CPU, being overworked? Is it constantly running out of short-term memory? Is the hard drive moving at a snail's pace? Literally any single piece of the physical machine could be our culprit.
And check this out. This is a perfect example of why measuring is so critical. In one case study, engineers found that switching to processors with 4 cores doubled the system's performance compared to processors with just a single core. And get this, the total processing power was the same. It's not about how much power you have, it's about how that power is structured. And you would never know that for sure without testing and measuring.
But here's the thing. Even the most powerful hardware on the planet can't save you from slow software, so our investigation has to go deeper, moving up from the world of physical computer chips into the virtual world of code.
I want you to think of your software like a giant stack of pancakes. Your app, the thing you actually use, is just the pancake on top, but it's sitting on a whole stack of other pancakes underneath it. The operating system, all kinds of supporting libraries, and a problem anywhere in that stack, even way down at the bottom, can make the whole thing wobbly. That's what makes finding the bottlenecks so darn tricky.
So with all these different layers where a problem could be hiding, where in the world do you even begin? The answer comes from a simple but really powerful idea called Amdahl's Law. It basically says this: if you have a team of 10 people working on something, and one of them is working super slowly, it doesn't matter how blazing fast the other 9 are. The whole team's speed is limited by that one slowest person. Your job is to find that weakest link and improve it.
And to find that weak link, engineers have a secret weapon: diagnostic tools. It's kind of like a doctor using a stethoscope to listen to your heartbeat. These tools let them peek inside the running software and see exactly what's going on. Is the CPU maxed out? Is the system struggling to read and write from the hard drive? The data tells the whole story.
So, what happens when you combine this scientific approach, this detective work, with the right tools? Well, the results can be absolutely incredible.
Let me tell you a quick story. There was this team of engineers, right on the verge of launching a new product. They added one last little piece of code, and the whole system just tanked. Performance went through the floor. They were in a total panic, trying everything they could think of, but every attempt to fix it was a dead end. They were completely flying blind.
And then they had a breakthrough. They stopped guessing and started measuring. They fired up the diagnostic tools, looked deep inside the system, and what they found was shocking. The culprit was one tiny piece of old code, something called a legacy trigger that wasn't even needed anymore. They just disabled it, and the results, well, they were amazing. As you can see right here, the system's throughput skyrocketed from just 16 operations per second to 85. It was suddenly almost 6 times faster. It was like they found and cut loose a giant, hidden anchor that had been dragging them down the whole time.
And that is the real magic of this whole approach. It's not about being some kind of programming genius or pulling all-nighters. It's about being a smart detective. It's about following the clues in the data to solve the puzzle. And when you do that, you can achieve some pretty incredible things.
So, if you're going to remember just one thing from all of this, let it be this: don't guess, measure. Performance isn't an opinion, it's a cold, hard fact. And when you have the facts on your side, you have the power to make a massive difference.
So the next time you're stuck, staring at that spinning wheel, don't just see a problem, see a puzzle. A puzzle that, with the right approach, can absolutely be solved. And who knows, maybe you'll start thinking about the hidden bottlenecks that are slowing down your world.